SpaceMobile podcast.
We just basically turn their phone and be seamless. Regardless of where you are, we don't want the user even to know that it's connected by satellite. Listen, the opportunity that we have is very, very, very large.
Hey everyone, thanks for joining. I wanted to fire up a space and just talk about AST SpaceMobile quickly because I think the tweet overnight definitely is worthy of discussion. And so for those that don't know, yesterday this company Space published a photo which they took of Bluebird 6 with the antenna array fully deployed. You can see the large phased array in the foreground, and then in the back of the tuna can that we call it, you can see a bit of the tail. And so what's great is that now we obviously have visual confirmation. Probably, the company would have preferred not to have had this image out there because I think the fully deployed satellite they would have probably have liked to have kept under wraps for as long as possible, just from a competitive perspective. Although you can assume that any competitor that wanted to get a look at this thing probably could pay any number of companies to get a picture of it. And I'm sure the Chinese have analyzed it very closely with the various space assets that they have. But yeah, it was great to see the satellite out there in space. And then we were fortunate enough to get AST SpaceMobile to retweet it. Obviously the cat's out of the bag, so they decided, hey, let's just go ahead and go with this, and we'll turn this into a cool tweet. And so they talked about the fact that they gave a hint as to the performance of these Block 2 satellites. And so in the tweet, they say, take a peek at Bluebird 6, the largest commercial communications array in LEO, as seen from space. 2,400 square feet, designed to connect directly to everyday smartphones, expected to greatly exceed 120 megabits per second peak data speeds. And so I wanted to talk about that in particular, especially in light of SpaceX coming out very publicly at Mobile World Congress talking about achieving potential 150 megabits per second peak speeds for their V2 satellites. And so, this is something that they pounded the table on. And then, of course, the company's proxies, which, of course, AST has proxies as well, which are people like me. But some of the X proxies for SpaceX, they pushed out that information, which was a bit, I would say not fully accurate, because then the folks that were pushing this information were saying that individual users could get 150 megabits per second, peak data speeds, which is true if there's only one user in a cell. But then if there are multiple users in the cell, then they would have to divide that speed amongst them. It's just like the analogy would be, cable internet. If everybody in your neighborhood is using it, then the speeds go down because that the throughput for a particular part of the neighborhood is shared. And so obviously not everybody is on the internet at the same time, or they're not doing something super data intensive. And so it's rare that you will really feel the pinch, if a bunch of people are using it all at the same time. Unless you're streaming something, but even then, for example, on your phone, if you're watching video, that's typically, degraded down. Maybe it's standard definition, because on the small screen, you don't need obviously the high resolution. But yeah, this disclosure from AST, they talked about expectations to greatly exceed 120 megabits per second. And by the way, AST is under the same constraints. That's 120 megabits per second within a cell, right? And so within that cell, that footprint, if there's like 5 users, then they're not going to get unless one user is doing something and the other 4 are reading, but they don't need it's not drawing data demands, then they would get 120 megabits per second peak speeds. But if all 5 are using it at the same time, then you would have to divide that capacity by all 5. But the disclosure, the key thing that I'm interested in, and this is, by the way, this 120 megabits per second figure is something that the company has discussed or disclosed and presented at length for a number of years. And in order to achieve that, you obviously need additional spectrum, right? Because at least for now, what's disclosed is that we're currently around 4 bits per hertz in terms of throughput, but that's expected to improve, and I'll talk a bit more about that. But 120 megabits is something that they kind of viewed as the standard that they're looking to achieve. That said, there are other technologies out there that the company will bring to bear, which is like MIMO, where you utilize 2 satellites to increase capacity and throughput for a specific cell. So they're both beaming down to that cell. Then you also have carrier aggregation. What does that mean? You're actually sewing together a bunch of different spectrum. And if your phone has the ability to do carrier aggregation, then then you can achieve even higher speeds. And so AST SpaceMobile satellites can do 2 of those things together to increase throughput, right? And so, but besides that, there are other technologies like Cohere, which is using different frequency, adjustments where they can potentially increase throughput of terrestrial and satellite networks, several multiples. But this disclosure last night, though, it's unclear what they're referring to. What technology would be used to greatly exceed 120 megabits per second. It may just be that the performance is going to be higher in individual satellite. And so that's what I wanted to focus on, where this disclosure, perhaps, and this would be a master class type of move, but for AST to kind of stick with 120 and just, keep pounding the table on that, it would be really funny if that was part of their plan. Like, we're going to keep pushing 120. And then of course, SpaceX, not to be outdone, Starlink says, hey, we're going to do 150. When in fact, in their back pocket, AST is like, actually the real number is 200, but we're not gonna spring that on everyone until the constellation's up and running. And that's actually a possibility, right? And so going back to let's talk about SpaceX and Starlink for a second. So for Starlink to achieve right now, I think they get around 4 megabits per second or 6 megabits per second per cell, to be shared by all users with their current generation direct to cell satellites. Let's call them V1. They have a very small phased array. It's like 2.5 meters by 2.5 meters, around there. But they're really, crappy service. It's a minimally viable product, right? It's for texting, low band data. Even recently, I forgot what the advertising association is called, but T-Mobile has, because of complaints, they had to walk back their claims, right, that they can do broadband data or any of this stuff. But they're going to be coming out with this V2 satellite. It's much bigger. And so it's kind of funny because the industry used to be like, hey, we don't need something big. And what AST is doing is terrifying. But then everybody is moving towards bigger satellites because that's what you need in order to communicate to a low-powered antenna in your phone. You're going to need a very large aperture that's high-powered and can beam down very accurate and effective signals to your phone. And so Starlink is moving. They're developing this new satellite called V2. It's going to have a 5 meter by 5 meter array, so much bigger, but not as big, obviously, as what AST is wielding. And this is, I think they're going to have 20 kilowatts of power generation versus what AST is doing today, which is 100. Let's call it 100. But that satellite's going to be better, right? But it's going to still have a regenerated architecture. It's all the brains and processing, the E-node-B, is going to happen in the satellite. And then we believe that they're going to try to do software-based fixed cells and try to compete at that level, right? And so there's going to be some compromises, as always, with their architecture, and because obviously they want to keep it backwards compatible with what they already have in orbit. But to achieve 150 megabits per second peak speed, it's going to require an entirely new satellite, right? And that satellite requires bigger and doesn't have the novel unfolding mechanism. It has kind of a more traditional unfurling type of solar panels, and then the phased array gets I think it's within the satellite, but then it gets pushed out and maybe it unfolds in a certain way. But that satellite is going to need Starship to be fully functional and on a commercial cadence to get launched. And so it's going to take time for them to get there, right? 150. Whereas the satellites that we're pushing out today, granted, it's taking quite a while, but the Block 2 satellites are already going to be at this 120 megabits per second peak speeds. But then last night we were told expected to greatly exceed that. And so the first question you have to ask yourself, and for me, having been a former investment banker and advised companies on M&A deals, and when you do that, you're always, and also public disclosures, whether it's earnings or other type of events, you're always asking your general counsel and your outside legal counsel, what is the threshold of materiality, right? And so if I make a claim, and I'm a publicly traded company, what is the threshold of what is material, what's not material? Do you say greatly, materially significant? All these different type of adjectives. Where if you go to a legal advisor, Skadden Arps, you pick any number of these, corporate attorneys, you would ask them, what's permissible, like what can we say that's not going to get us into trouble, right? And maybe for us to not get sued. And so when going back through what was disclosed last night, I kind of went through the exercise of what I used to do as a banker. It's like, okay, what threshold legal level would a internal general corporate counsel be comfortable with you saying greatly exceeds 120 megabits per second, right? And so just to give you some idea of levels, right? Like let's say the service could get to 140 megabits per second. Like that would give you, so that's like 20% higher than 120. That would meet the materiality threshold, but it would be very thin. It would be moderate. Like you're still opening yourself up for legal, implications, because you're saying greatly exceeds and then 144, 100, call it 150. That really is like moderately exceeds. It doesn't really meet the threshold. And so I think if you were an attorney that was kind of fast and loose, you might say, okay, well, yeah, you can go out with those words. But if you were a good practicing attorney, you would say, no, that doesn't, you can't go out and say greatly exceeds if it's only 140. Where you start getting into the realm of comfort, where you could say, okay, yeah, that greatly exceeds. I think 180 would be defensible. Like, 50% higher than 120 would be greatly. That would be kind of fair, and seem like a proper characterization of technical superiority, and so that could fit. But then I think and then if you're a really conservative attorney, you might say, okay, if you're going to say greatly exceeds, then you have to prove to me, or you have to feel comfortable, or the roadmap has to show, or the satellites currently do this, that they can get to, call it, north of 200, right? 200, 220, 230, 240. And so that's why this disclosure last night, I think, is really important, because the company is like very careful about some of these claims, right? On the one hand, obviously, they're doing their best in terms of meeting timing deadlines for launch and production. But when it comes to these type of claims, like I think they're very careful, right? And so to make the claim that greatly exceeds 120, I think you're probably looking at 180 megabits is kind of the low end. That's somewhat defensible. But to be safe, you should be probably comfortable with the fact that the satellite can deliver 200, 220, 240, right? And so now the question is, like, is that level something that an individual satellite can deliver? Does it need like coherent technology, or are we talking about MIMO? And so just to peel that layer back a bit, I think it was like in 2021, 2022, there was an article where Abel was interviewed, and someone had asked him, how fast can these things go? And this was obviously way back long ago when the satellites were still a concept, right? And so according to him, with MIMO, you could get to, call it, 750 megabits per second peak speeds within a cell, right? MIMO meaning you're utilizing more than one satellite. And so it's not another one possibility that an individual satellite could get to 200, 240, depending on how much spectrum you're using. Obviously, if you throw more spectrum at the problem, then you can definitely get the speeds higher, right? And so that may be it, but it could be a combination of these things. But what's interesting is that in the Q4 update, and I remember when I heard this on the call, I did a double take. I was like, "What was? Did I just hear that correctly?" And this is what I tweeted today. There was a question from Leiden, who's a retail investor and asks thoughtful questions. He's someone that we all know quite well, but in particular, I think you know, Abel was answering a question, and he kind of hinted at the ability to go at higher speeds, and not necessarily in combination with other satellites, but using AI. And so here, let me just read this. So this paragraph is, he says, now we do see many other opportunities for the technology that we are starting to see usage of them. One is radar, another is power generation, the AI data centers, hint, hint. Another one is multiplying the spectrum usage. So that in and of itself, that could hint at, utilizing AI algorithms to use spectrum more efficiently, but then also it could be pointing to the company's partnership with Cohere. And let me finish this. So we believe in we believe in combining our large aperture with our AI capability will create a multiplier for the spectrum. So the 50 megahertz we have, it will fill a multiple of that. It could be 3 times that. It could be 10 times that. And so that's the first time I've heard that. 3 times, that seems reasonable to me. 10 times, what does he mean by that? And so when you look at multiplying spectrum, it's not leveraging multiple satellites. It's just using one satellite, but then using AI to more efficiently, I guess, reuse the spectrum and deploy it. And so to get, capacity of 3 times and up to 10 times, it seems like they're doing some pretty interesting things on the engineering front, right? And so that's why I think, with that update last night of the greatly exceeds 120 megabits per second, and then you kind of tie that back to what was said in the Q4 call, which I think all of us were surprised. We heard that and we're like, okay, what does he mean by that? I think there's this roadmap. There's a plan for the, what has been generally for the last several years, kind of the minimum threshold of 120 megabits per second peak speeds. Now the company is looking to extend well beyond that. And from a competitive perspective, let's just say, the current satellites, they can do 120. There's probably going to be perhaps a multiple of that. And then, of course, you're going to have Block 3 satellites and Block 4 and Block 5. So there's going to be multiple iterations. Whereas Starlink is now, they're delivering, just for comparison, their current satellites that are out there direct to cell, they can do 7 megabits per second per cell. And then, Abel saying we can do with our current satellites 120 or perhaps more, right? Perhaps 3 times that, perhaps 10 times that. 10 times, I'm not sure what he's referring to, but he said it. So they're thinking about it. There's some type of development going on, and it's in the realm of possibility. And so then you move on to Block 3 satellites, which are going to be, starting production at the end of this year, and they're going to be leveraging mid-band spectrum, which, for those that don't know, mid-band spectrum is 2 gigahertz around there. It's what essentially what Starlink uses today. So it doesn't have good coverage or propagation, but it can carry a lot of data. And so that satellite, once that gets deployed, where do we end up with peak speeds, right? Imagine your phone, if you can do carrier aggregation and you're talking to a low band Bluebird and a mid band Bluebird, what throughput could you achieve with that, right? Because the mid band Bluebirds are going to have much higher data throughput, just given the spectrum that they're using. And so, yeah, it's I don't know. I'm kind of dumbstruck, right? The potential service levels that we might achieve with subscribers, whether that's consumers or government or military, is probably in. I think the company is kept this stuff on the wraps, right? They're not they're pretty secretive, and I think that's to the frustration of a lot of new investors. But for people who've been around for a long time, is kind of par for the course. Like they don't um, they don't pound the table and give away all the cards, right? Like they only give what they need to, and whether that's satellite design or parameters. Like if you talk even private conversations with management, like they don't tell you a ton when it comes to specs or what they're doing behind the scenes. But now we're starting to see some hints of that because I think obviously the company is now at this point of approaching commercialization, and so some of these competitive things, like they're going to be pretty well known, like because the service is going to be up and running. And so I feel like maybe the company at this point is more comfortable in disclosing these things. Um, but I feel like this, we're at this point where maybe our expectations aren't high enough, right? In terms of what the service is actually going to be. And, the company, if you see Scott at investor conferences or Abel talking, they speak they're very confident from a competitive perspective and the service that they're going to provide. And obviously the M&O partners, they keep putting money into this. And so, and they obviously know the roadmap and have seen it. There was a hint of this, I think, in 2024 when Lightshed Partners had hosted one of the decision makers at Verizon and asked, "Hey, why did you guys pick AST SpaceMobile over, Starlink?" And they said, "Well, we evaluated both companies' roadmaps, and we just viewed AST as much more attractive." And so I think now is public investors were starting to see that, right? Like the company is now they're coming out and they're dropping the hints, right? So 3 times to 10 times of what they had originally disclosed. And then you've got this tweet overnight greatly exceeding 120, right? And so again, going back to the masterclass, example, what if AST is like, hey, yeah, 120, 120, 120, and then Starlink's like, okay, engineers, we're going to focus on beating that. We're going to be 30 megabits per second better. And then when the constellation is up, AST is like, surprise, bitches. It's actually 200 or 240 or 250 or whatever it is, right? That would be hilarious. That would be absolutely hilarious. And the market would be in complete shock, right? As would I, or perhaps not us, right? Because we're kind of ahead of the curve on this stuff. But yeah, that would be a competitive masterclass of for your fast following competitor. You basically give them the wrong breadcrumbs, right? You say this is what we're engineering towards, and then at the last minute you're like, surprise, actually it was much higher. And so you've spent all this time and energy. For example, Starlink is they're working on their ASIC right now, and maybe that will take, I don't know, another 2 years, 3 years. But what if I think someone at Max 33 has said that Starlink had been working on developing this ASIC for the last year or two. And so what if they were kind of focused on developing that ASIC with a specific performance threshold in mind, and it ended up being well behind what they have to go deliver versus the competition? Like that would just be hilarious. So, but yeah, that's kind of what I wanted to discuss. I mean, obviously, there's I tweeted yesterday, as we continue to wait, we've got this launch coming up. I do want to say, unfortunately, I'm not sure I'm going to be able to make the launch. Like if it's at the end of this month, we've got spring break plans, and so I might have to watch it online, which is okay because I think I resigned myself to the fact that there's going to be a lot more Falcon 9 and Blue Origin launches. It won't be as cool as the first ever Blue Origin launch, but yeah, depending on when the date of launch gets set, which I expect it will get set pretty soon, I may or may not be able to make it. But aside from that, I did point out like we've got the FCC application kind of being mulled over and U.S. market application can be granted any day now. And then we've got some speculation. We talked about the company kind of made it seem like instead of a batch of 3 or 2 batches of 3, we're going to get 1 batch of 6 delivered in April. And so what does that mean? Well, that could be a batch of 6 getting split up into 2 for Falcon 9, or then the latest theory that we have is that either New Glenn 4, which got a special temporary authority yesterday to launch, either 4 or 5 is going to take up a batch of 6 sometime in May. And so for those that don't know, Blue Origin filed for an STA, special temporary authorization for Blue Origin, New Glenn 4, 5, and 6. And so yesterday 4 got approved. I'm assuming that 5 and 6 will get approved this or next week. And based off our due diligence, I don't think they have enough payloads to fill all 3 of those. And so it's likely that one of those, at a minimum, perhaps 2, will be for AST SpaceMobile. And as we know, Scott reiterated 45 satellites launched at a minimum this year. And so in order to achieve that, it's either going to be a lot of Falcon 9s or many Falcon 9s, but then also a few new Glens sprinkled in there delivering 6 satellites. And so exciting times. I know obviously everyone's concerned about the current conflict in Iran, and the market day to day trades on tweets from administration officials, or what Trump is saying, or what is Iran saying. But it's important to, in these type of environments, to know what you own and understand the risks, right? And so I think for those who have followed the space sector, and for AST SpaceMobile in particular, you've got massive tailwinds, right? Because with conflict comes more defense spending, and obviously it's not just Iran as an adversary, but unfortunately there's China, there's Russia, and space leadership and sovereignty. There's this saying, "He who controls the sea controls the world." And I have this investment in Kraken, which is a play on that. But then I was thinking this morning, like, there should be an exact mirroring of that statement of "He who controls space controls the world," which is absolutely true. Like, if you look at this current conflict, the U.S., by having observation, intelligence, communications, GPS, all these different capabilities in space, it allows the U.S. and allies to control that theater, right? Like bringing to bear munitions that are laser guided, or that depend on space guidance. You've got fighters, bombers, all kinds of things, right? Ships, vehicles. And so I think what this conflict has kind of shown is the fact that you need to have absolute space dominance, and be able to leverage the technologies, because it becomes, as Pete Hegseth has said, we're not going into these fights looking for a fair fight. We want to have an overwhelming advantage, right? And so in order to achieve and maintain that advantage, it's going to require ongoing and continuous development of space assets, right? And so AST's in the nexus of that, as are some of these other companies as well. So there's going to be machinations, like noise of the market up and down, but one thing is absolutely true and undeniable. It's the inexorable rise in spending from defense for space, right? And so putting aside commercial applications, we want to have military superiority in space. And as part of that, money is going towards these companies, whether it's AST, Rocket Lab, Karman, any number of these, companies that are focused on, Planet Labs, for example, Black Sky. All this stuff is what gives us edge, right? And so in an environment where the markets are uncertain, what you can be certain of is defense spending and money going to these companies in order to keep US at the forefront. So I'll end it with that. But yeah, I think what an interesting disclosure from the Q4 earnings call, and then tying that together with the tweet last night. I think there's great things ahead, great expectations here. The need for speed, right? And so while Starlink continues to catch up and they're aiming low, we're aiming pretty damn fucking high. I'll end it there. Thanks.
Thanks Thanks for listening to the AST SpaceMobile podcast. If you enjoyed this episode and you'd like to help support the podcast, please share it with others, post about it on social media, or leave a rating and review. To catch all the latest news about AST SpaceMobile, make sure to subscribe. Thanks again, and I'll see you next time.
We're doing something very, very big. And I think with this technology, we can really affect billion lives. AST SpaceMobile is the only company that has proven technology to deliver cellular broadband connectivity directly from space to the everyday smartphone. People will just basically turn their phone and be seamless, regardless of where you are. We don't want the user even to know that it's connected by satellite. Our role is to bring this into reality, always in partnership with the MNOs.
Listen. Waffle.